I gotta tell you how to do that, right?
Oh, sorry for the delay again, just got trapped on the phone and looked at my watch and said, wow. All right, we'll be keeping it relatively light today. Okay. So, finish up chapter 18 and then just get started briefly into chapter 19. Remember last time we were looking at reducing a carbonyl, okay? And we reduced it last time to remember what alcohol, okay, using lithium aluminum hydride, sodium boryl hydride. Today we're going to reduce it even further to a CH2, okay? So we're going to have a more powerful reducing agent to do this. Okay? And in fact, there are two different ways to do this reduction. First way is what's called the Clemenson reduction. Okay? And remember we did this back in benzene chemistry. Remember that, where we had a acyl group on a benzene ring, okay? And then we reacted it with zinc and mercury and HCl. Okay, remember that reaction? And what did that do? That converted the acyl group to an alkyl group. So we got something like that there. Okay? But here, it just doesn't have to be on a benzene ring to do the reduction. Okay? So note, we have converted carbonyl to CH2. Okay? It doesn't have to just be on a benzene ring, it can be on a regular molecule like that. Okay? We didn't really consider that last time. So if you just have regular, say, butanone, and react it with zinc, mercury, and HCl, that would convert to the CH2 there as well. Okay? So it's a very powerful reducing agent where I've gotten rid of all the oxygen, there's no OH, and just gone all the way down to the CH2. Well, there's a second way to do this reaction, okay, to give us the same product. Let's look at it right here. Okay, the second way is what's called the Wolff-Kishner. What does a wolf do?
I don't know.
What else does it do?
Eat.
Okay, like to take a bite. Remember that commercial? Takes a bite out of crime. Okay. Well, here, let's see what this does. Okay, we react react it with this molecule here. And then secondly, KOH. Okay. And this NH2 is called hydrazine. Okay. It's sometimes just shown as the molecular formula N2H4. Okay. But this is the Wolff-Kishner reduction with these two reagents. What it does is it takes a bite and it bites off the carbonyl and it converts it to the alkane. Okay. So, see the same kind of thing on rings. Where here, it would take a bite, it would bite off both carbonyls and give you the cyclohexane. All right, so be familiar with both ways of reducing a carbonyl to CH2. Okay. Before we close up the chapter, let's do one kind of synthesis reaction. Let's suppose we had this molecule, cyclopentanol, and we wanted to convert to regular cyclopentane. Okay. Any ideas how we would do that synthesis? Okay, very good. Need to turn the alcohol to a carbonyl. Do you remember what we used to do that? PCC. Okay, so that oxidizes to the carbonyl. And then what can we do? Well, one of the two reactions we just looked at, the Clemenson or the Wolff. Okay? You guys seem to like the Wolff, so let's stick with the Wolff. So I use the Wolff-Kishner to bite off the carbonyl, and so get cyclopentane. Okay. So any questions on those reducing reagents? Okay. Well, that finishes up chapter 18, okay, on aldehydes and ketones, okay? And now we'll move on to chapter 19. Okay. Chapter 19 deals with amines. Amines. Remember what amines were? What special atom were we looking at? Nitrogen, good. Remember the imines. Okay. So, amines is where we have at least one kind of carbon group on the nitrogen, okay? And amines come from this molecule. Does anybody know the name of that molecule?
Ammonia.
Ammonia. Okay, so you see the AM, so that carries over to the amines. Okay. Well, let's get introduced to amines. By looking at some different types of amines.
Yes.
So let me just draw some different amines up here. Okay, so here's some different amines to get us going.
Yes.
Okay, so amine types are kind of like the same thing as alcohol types. Okay. What we do is we look at the nitrogen and ask how many carbons are attached to it. Here we just have one, so this will be a primary amine. Okay. If I come to this molecule here, how many carbon groups are on this nitrogen? One, just one here. So this is a primary amine. Okay. How many carbon groups are on this nitrogen? Two. One and two. So this would be a secondary amine. What about this one down here? Tertiary amine. Okay. Now this thing over here where we have positive charge of the anion, this is what's called a quaternary ammonium salt. A quaternary ammonium salt. Okay, and we'll talk about these more a little later. Okay. But these are the amines that we want to get used to here. Okay. So what we're going to do now is shift and learn how to name these things. Okay. So let's get more acquainted with them and naming them. We're going to go through a bunch of naming here, all right, of different kinds of amines. Let's start off with the simplest ones first. Suppose we looked at that one. Okay, these are very simple to name. All right, you see a nitrogen, so it's an amine. But we have what? A methyl group. So we just call that methyl amine. Okay, pretty simple. What do you think the name of that amine is? Okay, you have two ethyl groups. So diethyl amine. Okay. Pretty straightforward, aren't they? Okay. And all the groups don't have to be the same. Okay, so what would you do? Just name them in alphabetical order. Here you have two ethyl groups. So you have a diethyl, methyl, amine. Okay, so you just put it in alphabetical order. So any questions on that round of amines? Those are pretty easy, aren't they? Okay. Let's go to the next round of amines. How will we name amines like this? Okay, a little bit different, aren't they? Okay, so here, a little difficult to name this group. I mean, you could name it sec-butyl amine, okay, if you really wanted to. But here, it's a little bit easier to call this a group. Okay, NH2 as a group is called the amino group. Okay, so name the parent chain as a butane, and so that gives us 2-amino butane. Okay. So the word amino, what does that make you think of, say from biology? Amino acids. So guess what amino acids have in them? These NH2 groups. Okay. They're just on carboxylic acids, and so that combination. Okay, let's look at this one here. Okay, so the amino would get priority. Okay, so the two groups are trans to each other. So trans 3-chloro. Amino cyclohexane. Okay, you could even just drop the 1 out of there because the amino group has priority. Okay, but either way is fine.
Is it reactive?
Yeah, thank you. Okay. Okay, so put the A before the C. Question?
Can the one also be dropped out of that one?
Yeah, you could drop that too, because the amino is understood to have the 1. Okay. Okay. But when I'm never sure, I just like to include the numbers. That way, the reader will know what that thing is. Okay, so that's how to handle the amino group. Okay. Let's look at our next class of amines. So if I remember what the name of that aromatic amine was. Aniline, good. Okay. So aniline, but let's modify aniline a little bit. Let's modify it to that there. Okay. Here, there would be two different ways to name this molecule. Okay, let's look at one way. What we've done is we've put this ethyl group on the nitrogen, so the way we can tell the reader that is I write N-ethyl, meaning the ethyl is on the nitrogen, and then aniline. Okay. N-ethyl aniline. Everybody see another way to name that molecule? If you were to try to name it as an amine, how would you name that as an amine? Got this group, which is what? Ethyl. How about this? Very good. Okay. So you could also call this ethyl phenyl amine. Okay. About the name of this thing here. Be the name of that. What's the name of this whole group here?
No.
The benzyl group, good. Okay? So we could call this benzyl amine. Okay, so that's the next wave of amines. Let's do one more wave of amines, which is again totally different. Okay, this has to do with cyclic amines. Cyclic amines. So let's look at some different cyclic amines. Okay, see how the nitrogen is part of the ring? Okay, there's that one there where we take the double bonds away. There it's part of the aromatic ring. There it's part of a six-membered ring. Here we can have a couple rings fused together. So these are cyclic amines. This last one here is called purine. Okay. Coming back here, this is called parole. Parole or Next one is pyrrolidine. And then we have pyridine. Pyridine, very popular amine. And then this six-membered one is called piperidine. Okay. Have you heard of any of those cyclic amines? Probably maybe heard of purine. Okay. Used again in DNA, part of the bases. Okay, so those are the names that you want to be familiar with. Okay? Any questions on naming amines? Okay. All right, let's look at something different about amines. Again, we're just getting introduced to them. Look at some properties of amines. Anybody guess what special property amines have? Okay, they have a certain smell to them. What do you think they smell like? Think they smell good? Okay. You ever open up a bottle, you'll immediately smell like dead fish. You ever smell dead fish? You like good fish, don't you? Like catfish? What's your favorite fish?
Catfish.
Catfish? You don't like salmon? Okay, so anyway. They have very strong odors. Okay, if you ever open a bottle of any of these amines, pyridine, any of these things, they have a really rancid smell to them. Okay? You never want to get any of it on you, your skin or your clothes, because it stays there for a very long time. Can't wash it out. Okay? So that's the first thing to remember about amines. The other property that we're going to spend a lot of time on next time is that these are basic. Amines are basic. Okay? Remember, if something is a base, what do we need to have on it? Lone pair. And the nitrogen has a nice, juicy lone pair on it. Okay? So we're going to find out that these basic properties are very important. Okay. Let's say we compare that to water or even an alcohol, okay? And we'll close with this today. Water has lone pair, doesn't it? So water can act as a base. But the question is, which is a stronger base, water or that amine? What do you think? The amines, okay, since we've been talking on, they must be stronger, but the question is, why are they stronger?
Because water is neutral, right? Is that what we?
Okay, that's neutral, but so is the amine. There's no charge there. Okay, so good try there. Any other reasoning why the amine is a stronger base? Look at the periodic table.
Does the nitrogen atom combine?
That's electronegativity.
Okay, yeah, so the oxygen is more electronegative than the nitrogen, isn't it? Okay, so that's where the difference lies in. Okay, so the nitrogen is less electronegative. Okay, the oxygen is more electronegative. Okay, so what does it mean if an atom is electronegative? Okay. So, so suppose she is more electronegative than me, she grabs a hold of the stick.
She gonna take.
What's gonna happen?
She gonna take.
Okay, so show me what happens if you're more electronegative. Oh yeah, she pulls me in. Okay? So, if I'm the lone pair and she's more electronegative, she's pulling me in. A base, the lone pair wants to go out and attack, but I can't, she's pulling me in, okay? So, here, the oxygen is pulling these lone pair in a little stronger, so they can't donate as much. Okay, here, the nitrogen's not pulling in, okay? So it's more free to donate. Okay? So this is the special property of amines that we're going to investigate next time. We're going to see all the reactions have to deal with their basicity. Okay? So we're going to look at amines. We're going to compare different amines, see which kind of amine is more basic. Is a primary amine the most basic, or is a tertiary amine the most basic? Okay? And get into that kind of classification. All right? So let's call it there today. You guys have a good spring break.